Hey y'all, welcome back to Alakazam Math Made Easy. If you watched the first segment review, the limits review, you'll know how this is going to go. Basically, what I'm going to do is I'm going to go through generally how I would prepare for, the derivatives, the first derivatives exam, right? So not going to go over a lot of review of content, mostly just what to review for the exam. And I'll refer you back to the videos that go over those in more detail, right? So the first thing you should know is you have to know the derivatives of all the types of functions we've covered, right? So polynomials, exponentials, natural logs, regular logs, trigonometric functions, and inverse functions. You have to know these, right? By heart. You should not spend any time whatsoever thinking about what the actual derivative is, because the assumption that the test writer is making is that by the time you get to the exam, you know this part and they're testing you on how to apply them or how to incorporate them into other steps. So if you want to review these, it's in videos 11, 15, and 17. But once you know those, jump right into the rules that you should know. That's product rule, quotient rule, and chain rule. As a reminder, those were in two separate videos. Video 12 went over product and quotient rule, then we covered a couple other topics, and then back to video 16 covered chain rule. And remember that these can be combined, right? Quotient rule can have products built into it. Product rule doesn't necessarily have to have two functions. Chain rule can have multiple functions, or it can be built into one of the other two. So my recommendation is once you get familiar with solving the individual rules themselves, like just two-part product rules or two-part quotient rules or two-part chain rules, expand it, try to do three-part product rules, three-part chain rules, quotient rules that have product rule or chain rule in them, and practice that. One of the other things that you don't necessarily have to solve every problem, but one thing that I would absolutely recommend doing is once you get comfortable solving the problems, just figure out, find a problem set and start practicing identifying which rules are where. Because a lot of the times on exam questions, it'll be find the derivative and it'll give you a function that has chain rule or product or quotient rule in it. It won't say use product rule to find the derivative of this, right? So practice identifying them too, because that's going to be a large part of the exam. And then the last thing you should know is some applications, right? So the first application we covered in video 13, which was rate of change with derivatives. And that basically just goes through how to find the slope of a tangent line given the x value you want to find it at. Remember, the first derivative is a function that will help you find the slope of a tangent line at any value of x. So the first step is going to be find the first derivative, and then you'll plug in whatever value they gave you into the derivative, and the value that you populate from that will be your slope of the tangent line at that x value. The second application you should know is how to find where the function is increasing and decreasing, and where to find where it's concave up or down. And that both of those topics were covered in video 18. They're very, 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 very similar. You'll notice that a lot of the steps are exactly the same. It's just there's an additional step in the concavity, and that's to find the second derivative. So in the process to find where a function is increasing or decreasing, you find the first derivative, set it equal to 0 and solve for x, put all those x values on a number line, and test numbers inside of each range divided up by that number line. So if you have one x value, you'll be testing two ranges. If you have two x values, you'll be testing three ranges. And if you have four x values, you'll be testing, or if you have, three x values, you'll be testing four ranges. So draw the number line, put the x's on them, and then figure out how many ranges you're testing and pick a number from any range. It doesn't have to be the next number up. It can be any number inside that range that's easy to plug into the function. And really, you don't care what the actual value is. You just care if it's positive or negative, right? So pick a number that makes that time efficient, right? And then when you get positive or negative, you'll be able to interpret whether that is positive meaning increasing or negative meaning decreasing. And then in that video also, I go through how to actually write where it's increasing and decreasing. There's two different ways. You can either write it as, for example, negative infinity to x to infinity, or you can write it as negative infinity to whatever number, union, whatever number, comma, infinity. And I go into those details again in video 18. The only difference at all between increasing and decreasing and concavity is that instead of stopping at the first derivative, you actually calculate the second one. And when you plug in, you set the second one equal to 0, you make a number line, you plug in the x values into the first, or into the second derivative instead of the first. But again, you interpret it, and then positive will correlate to concave up, negative will correlate to concave down, and that'll give you information about the function that way. The last thing that you should do, and I go over an actual example of this in video 18, but the last thing you should know how to do is combine increasing, decreasing, and concavity to help you find a rough sketch of the graph. That's usually a question on every exam, because it's a nice robust way to see if you can figure out where it's increasing and decreasing, and simultaneously where it's concave up and down. So remember, my advice on this one is for increasing, decreasing, you find your values and you plug them into the first derivative. And that you should know, not necessarily by memorization, but logically, because you're looking in that case at slope. And for concave up or down, you want to plug everything into the second derivative. And that should, again, not be memorization. That should be because you're looking at concavity, and that's what the second derivative tells you. And then if you're looking for y values to build the rest of your graph, right, that you plug into the original function. And again, you should know that, because not by memorization, but because you're looking for information about the function itself. So the first derivative tells you something about slope, the second derivative tells you about concavity, and the function tells you about itself. So that is my parting advice for this topic. If you have any questions, start by referring back to the videos on the subtopics. I put each video number on each corresponding topic, and I'll put links to each video in the description of this one, so it's easier. If you have questions after that, leave them either in the video itself or in the comments on this video. I'll answer them as quick as I can. If you like this video, if you learned something from it, give it a like. If you want to keep up to date on new content in this channel, subscribe and turn on your notifications. And as always, best of luck on your exam.